Good morning. So today I'm going to talk about the Azure Kubernetes service. So this is a managed service which is provided by Microsoft. So if you must be aware, there are other services provided, managed services such as from Amazon, AWS, which is very famous, is EKS, and then Google also has GKE and Kubernetes service. So this is the Azure Kubernetes service, and this one, what I felt was that Azure has added a lot of features, and their strategy is, from what I understand, is to give you a complete managed service so that as a user you don't have to do a lot of stuff. So if you can see, if this I captured from their website, so if you can see, if we drill down, right, so this is the cluster. As normal, any Kubernetes cluster has master control plane, which will be managed by the provider, which will be Microsoft in this case. And then we will have the cluster nodes, which will be called the node pools, where the nodes will run and your workloads will be running. So that is called that is managed. So that is a different set of node groups which are given. So they have something called system node pool and user node pool. And when you're using a user node pool, which means that's where your workloads will run, you will definitely need an ingress controller. So it comes, they provide a traffic ingress controller, if you have heard of it. So it comes with this ingress controller. So in addition to that, what do you need in a cluster, right? Once you have your workloads running, you need to have some monitoring. So Azure provides a very good integrated performance and health insights of your Kubernetes cluster and your containerized application using something called, they have a true, they use Prometheus and Grafana. So basically it collects all the data logs and metrics, and in addition you can also bring your own, if you're like your company, or if you're using something else like Dynatrace, which is very popular for log monitoring and for also your monitoring of your workloads and their memory performance, and also for distributed tracing. All those features are part of Dynatrace, so you can bring it external also, so that becomes a part of it. And they follow a hub and spoke model, which is basically everything that comes in the on the hub is a part of, and then spoke is the external, your add-ons. And then they have also a feature of on premise. So basically it's something can be on the cloud and on the on premise. So like Amazon also has this, which is called EKS Anywhere. Similar to that, they have provided something which they call ACR. And so you can have your some workloads, if you want, you can have them running in your on premise, where your control plane will still sit on the cloud. And other than that, they have so they have key management system for security, where you can say a vault where you can save your secrets, kind of a sort manager. And they have a very good feature, again, as a part of, like, for AWS you have ECR. For Azure, you have ACR, which is called Azure Container Registry. So this one is where, when you are building your images, the images should has to be in a registry before the container can start. So the container will pull the image from Azure Container Registry and run this. So let me go down to exploring and then sharing. So these are some of the notes I captured from KubeCon, where they're completely they're clearly saying that they are enabling us to achieve anything. And with the Kubernetes, and the ecosystem has a lot of capabilities for scalability and also using AI. So like for any system, they have flexibility for the capacity. So they use something, if you look on the other side, there will be work add-on management. There will be something I'll share in the next slide, like for scalability, where you have horizontal pod scaler and you can have vertical node scaling, and both are available in this. Then proactive workload resilience, effortless built-in security. This is a very good feature, because here they have a lot of features, including signing of the images and running containers in secure environment. Then they have boost developer productivity, building AI apps. So they are highly integrated with CI. So they have, like, you can have GitHub Actions that can be integrated with AKS. So you can have your code and then your workflows. altogether. And then they have cost optimization, performance and scaling, and cost optimization. So their tool uses Carpenter. So if you've heard of it, Carpenter can detect, it can help with the resource utilization by scaling up and down the nodes automatically based on your usage. So another good feature was chaos mesh. So chaos mesh is basically when you're running your workloads, you want to have some kind of chaos, Gremlin is a good product, but in this case they are using open source which is called chaos mesh. So basically what you have is it will actually inject, like faults, or it will bring down, let's say, your pods, and then you should be able to, it will kill the pod, or it will cause disruptions. So, or it will connect, make some delays or some kind of thing. So then when you are, every application should have, some kind of a testing, so that to simulate a real world scenario when something happens, your node goes down and your pods get ejected, or your network is down. So this will help for us to be ready for a scenario where anything chaos mesh will help us to, if if anything goes wrong. It's like kind of doing like fire drill, when we have fire drills in our organizations, like that. So it's actually simulating it, so that we should come out of it and find ways to get out of that disruption. So they use a product, it's called Azure Chaos Studio plus AKS. So it uses chaos mesh, and it falls which requires chaos mesh to be installed externally on the AKS cluster, and it can help with the pod disruption, resource pressure, network disconnect, etc. So it will create more aggressive environment. So then how your Kubernetes, how your environment will be able to survive those disruptions. So this is something very very good, I found. And then also they have very good feature, which is basically upgrades, like when you are running work. So now, even though it's managed by these services, managed by Azure or Microsoft, still the upgrades, they're always a pain. So if you have to upgrade, because normally in a Kubernetes cluster, what will you do to upgrade? You have to first upgrade your control plane, and then you will upgrade the workloads, which is node groups. So they have tried to kind of add a lot of improvements, where the newer latest, so 1.30 is the latest upgraded version of Kubernetes. So how it can be, how it can be made, and most of it is automated, so that users don't have to really worry about manual upgrades. So all this can be automated. And the another thing was scaling, as I was talking about, right? So we need a lot of, when you run, there are big workloads running on the Kubernetes cluster. So you definitely want something which is horizontal pod scaler, which comes, so what it does is it monitors the demand, and if there is more demand, then it will automatically add more nodes to the cluster. So that's horizontal pod autoscaler. And there is also something called scaling with KDA, which is basically pod scaling for like message based applications. So it can be used with horizontal pod scaler. And then there is scalar, then there is sorry and then there is scaling vertically, which means the vertical pod scaler is like an add-on which will dynamically, it will vertical pod scaling is it will add your resources based on the usage. So if you can see, so this is basically a slide which gives how the horizontal and cluster autoscaler will work. So the difference is in the horizontal pod autoscaler means it's autoscaling, it's adding pods. So if you're running 3 pods and you say your workload goes higher, if you start getting more requests from the users, you need, and then the pod scaler determines that, oh, the capacity, we need more pods, it will add more pods to it. Now when you add more pods, right, each of the pod is consuming some memory and CPU. So then your node can be out of resources. Then cluster autoscaler kicks in and it will add another node to the cluster. So this is the beauty of Kubernetes, and then they have kind of automated it so that you don't have to worry about doing any of this manually. So once you have everything set up, then during high peak seasons, or let's say any holiday season or anything, when the workload is more, it automatically it will kick in and it will take care of all the additional requests. So some of the tools that they're using over here, I'll just read it. They're using KDA HPM managed add-on to scale up the application. They're using cluster autoscaler with horizontal pod autoscaler for hands-off scaling. They use V4, V5, V6 VM SQs for faster VM provisioning times, and then they're using a lot of storage for that. And for artifacts, leverage artifact streaming for fast image pull times and container starts. And CNI overlay, they use Cilium, which is best in class, and it's very good product. And then they also have introduced something called Azure Linux, which is a lightweight container. So just they have their own Linux version, and then you can use it, like the like Amazon has Amazon Linux, right? So they have their own Azure Linux. It is lightweight, and then they will you can run the container like EC2 instances, so they can be based on Azure Linux. So next slide I want to focus is now, so they have a lot of now security is a big thing when we are running all these big applications and containers. So from Azure, what they are doing is they have very good container and image security, which means that when the images are built and then they are having image signing, and then something called image scanning, which can be done as part of the Azure Container Registry. So you scan the image, so image gets scanned for any vulnerabilities, and if there is a vulnerability or threat, they are also making it, there's a image cleaner. They're using something I learned was called COBA. So I will discuss in another session, but basically that is used to automatically fix the vulnerabilities. So when your images are running, you want to make sure that there is no critical or high, at least when it's running in the production at least. And similarly, they have many control plane and Kubernetes related securities. They have option to choose the cluster to be private. The subnets can be private, so you don't have to make anything public. And it's all like IAM based, right? So all control is based on authorization and roles, policies, whichever only you allow. And then they have certification, of course, rotation. There is encryption on it at CD. They have various policies for authentication and authorization. Now, when we talk about node, every node itself has to have some kind of security, which means that it should be hardened. There shouldn't be any vulnerabilities on it, and there should be some kind of an encryption. There should be some kind of hardened node images that will be running, which means images shouldn't be running as root, and should always be run as a user, because if somebody gets access to the node, let's say, and they should not be allowed to exec into the container, so that should be blocked. So in case if you even allow somebody to exec into a container, but still if the container is not running as root, the harm a user can do is very much limited, versus somebody who goes in there and he sees a root, then he can do anything for that. Similarly, there is a lot of application and network related security, which means that they have Istio, MTLS and authorization. There are various network policies, which is a very good feature which I found was that there is so when the pods are running in a cluster, one thing is ingress, so how the traffic comes inside, which is north south traffic. Then there is east west traffic, which means how different pods in a multi cluster, how they will communicate with each other. So that's east west traffic. Even a single even a single cluster, so that is something called service mesh. And they have one more thing, which is like when the pods need to egress outside of the cluster, so for that they have various network policies that can be set up, so they can restrict or allow only to certain egress IPs, so they can be set up.